Hey, what's going on, guys? Let's see how we can find the intervals of convergence for this first question. So first of all, what we have to do, let's look at the general pattern first and then we do this one, right? The general pattern is first whenever we have some pattern like this, 1 over 1 minus x. If we don't have this pattern, we have to bring to this pattern, and whatever the value we are subtracting from 1, here we are subtracting x, right? So whatever we are subtracting value, we have to write the one in terms of power series representation. So here, if I write this one in terms of power series representation, this is going to be sigma n is equal to 0 to infinity, and whatever the value we are subtracting, here it's x, so this is going to be x power n, right? If you have anything else, that's going to be that power n, and we are going to have something like that, right? And whatever the value you are powering, here we have x power n. If it's 2x bracket power n, you have to bring 2x to this absolute value. So here, since we have x here, this is going to be x absolute value, that's going to be less than 1. From this one, we find the intervals of convergence. Now let's look at this one. We have to bring this one into 1 over 1 minus x format, right? So here what we can do is, we can write this one in different way. Like, instead of writing like this, I can write this one like 1 over 1 minus 9x square. It's the same thing. I just got 1 minus, that's the main thing. So 1 minus 9x square. So whatever the part we are subtracting from 1, that's going to be in the power series representation. So now we can go ahead and write this one in terms of power series representation. This is going to be sigma n is equal to 0 to infinity, and this value, I grab this one right here, minus 9x square power n, right? Now we have this, we have powered this one. Now this is going to be less than 1, right? This is going to be in absolute value less than 1. 9x square less than 1, and we know that whenever we have a negative value in absolute value, that become positive, because the absolute value of any negative sign is going to be positive. This is going to be a positive 9x square. 9x square less than 1. Now if we find the x square, that's going to be less than 1 over 9. I grab this, treat this one like an equal sign, and if you bring the other side, it's going to be 1 over 9, right? Now we have to find x. X is going to be, if we square root this one, this is going to be 1 over 3, right? From this one we can derive the intervals of convergence. So this is going to be negative 1 over 3 to x, and then we have positive 1 over 3. So this is going to be the intervals of convergence, and this is how we do that. Now let's see how we can write this kind of functions in power series representation. So this is the part we are trying to find now. Let's see how we can do this. So first of all, in order to do this, we have to bring this pattern first, right? 1 over 1 minus x. Now let's see how we can bring this function in this pattern. So here what we can do is, we can take the x common, right? And if I take x outside, this is going to be 1 over, instead of writing 4x plus 1, I can write this one as 1 plus 4x, right? Now, but we have to have 1 minus and a value, right? That's the main thing here. So to get that, what we do, we can write this one as x 1 minus 4x, like we did right here. We already did this one like this. So we write this one like this. Now we can go ahead and write power series representation. In power series representation, we have seen whatever the value we are subtracting is going to be the value that we going to power by n, right? So here we are going to have sigma n is equal to 0 to infinity, and we are going to have minus 4x power n. So this is power series representation, but since we have x value in the outside of this kind of things, this kind of pattern, we have to multiply this one by x. So x comes in front, and we will have this one, right? Now let's see how we can bring this x to this side and combine together. Now this is going to be n is equal to 0 to infinity, and we can write this one as minus 4 power n. I'm just bringing n separately, so this is going to be minus 4 power n, and now we can combine this x with this one. We have x power n here, and if I bring this one here, it's going to be plus 1, right? Because if you multiply x power n times x power 1, you will get x power n plus 1, and that's how we got this value. And this is going to be the power series representation of this one. Now let's see how we can do for this one. Same approach. We take negative x common, we factor by x, so this is going to be x times 1 over 9 plus x square, and then in the denominator we have to have 1 minus x, right? To get that one, what we can do here, again we can take 9 common, 9 outside, like we did x outside, so this is going to be x over 9, and if I take 9 outside, this is going to be 1 over 1 plus, we don't have 9 right here, right? So if I take now 9 outside, this is same as x square divided by 9, and if you multiply again, you will get 9, and this 9 cancels, x square, you will get x square again. Now we have the similar pattern. Now we have to have minus in front after the 1, so we can write this one as x over 9, 1 over 1 minus x square over 9, and that's it. Now we have brought the pattern. Now this is the part is going to be powered by n, right? So this part we are going to bring n equals 0 to infinity, and this is the part we are going to bring right here, minus x square over 9 power n, right? In the outside we are going to have x over 9. Now we have to combine this one with this one. Now let's go ahead and do that. So this is going to be sigma n is equal to 0 to infinity. Now I can take negative 1 separately, negative 1 power n, and then x square. So this is x power 2n, and if I bring this n x to this side, this is going to be plus 1, right? Same as the we did here. We have x power 2n already, and if I bring this x right here, this is going to be x power 2n plus 1. So that's how we got this one. And in the denominator we have 9 power n already, and if I bring this 9 right here, this is going to be 9 power n plus 1, and now we have the power series representation. And if you want to find the intervals of convergence, you just take this part, the power n part, and then you do the same thing, less than 1, and after that you solve for x, and that's going to be minus and plus, right? That's how we do that's how we find the intervals of convergence. I hope you guys find this video helpful. See you next time.